always going to be given to you 5' to 3'.
Coding DNA is 5.
Yep. And then what's our other strand called, guys?
Template.
Template. Template's going to be 3 to 5. And so what's our RNA orientation? 5 to 3. Yep. And our mRNA is going to look exactly like our coding strand, except what? Okay. So if I gave you the template strand, could you give me the mRNA? Yes. What would it look like? It would be complementary. Again, please insert.
And we can use anything we draw on our extra credit thing on the test.
Thank you for bringing that up.
That's appropriate for glycolysis.
I was gonna say, I will be
Krebs.
looking at all of them before you take them to use. So, no extraneous information.
But it
Simply
can have everything that has to
substrate,
do with it.
enzyme, product. So I want to see the pathways. If you want to write down how many NADHs, how many ATPs, I don't care about that.
Okay.
Okay, but there better not be like a, and this right here is the definition of, I don't know, of group translocation. And here's the definition of it, like just substrate, product, enzyme, maybe your ATPs, NADHs, and FADH2s. Okay, cool. Anything else? Your friends will love you if you make it really big and they can use it too.
She's not here, I'm sitting there.
Does Philip know about the extra credit?
So I just wanted to.
Oh yeah, he wasn't here.
This one.
What's it asking?
I'll email him.
And stuff, like online. it
Oh my
won't
gosh,
let
I've sent him
you-
like a million
like, there's
emails.
no
I
words
just
to
emailed him.
answer. Like, it gives
Oh,
you
really?
1, 2, and
Okay.
3, but there's no boxes that you put into typing things.
Oh, good to know. Okay, so,
What? Say that
so
again?
for the question that gives you, I give you the coding strand,
Yeah.
I think. So I give you a coding strand, it's basically the example that we worked through in class just with different nucleotide sequence. She's saying that it doesn't allow you to type in an answer to send it in to me. So if you, it's totally up to you whether you would like to write that answer out and turn it in handwritten, you can do that the day of the exam, or if you would rather email me your answer, you can do that. Sorry about that. Online. Love the interwebs. Anything else?
You guys had a bunch of questions this morning,
We still have to answer.
What were they? Is it anything
Yeah.
There was that one
everybody else might
about-
benefit
We're
from?
talking
The
about
substrate level and the oxidative phosphorylation.
Yeah. So what I want you to know in regards to substrate level versus oxidative phosphorylation. If I were to ask you to compare and contrast those guys, for example, number one, do not tell me they're both phosphorylation. I know that. I told you that in the question. But what I really want you to be able to know about that is, one, where is this occurring? Which pathways? So substrate level phosphorylation occurs where?
In the substrate.
Glycolysis, Krebs cycle. And in fact, while we're at it, let's just go back and look at that.
Do you work today? No. That's nice. Thank gosh.
I'm gonna start on my assignment.
Okay, so a great example of substrate level phosphorylation
Well, I started on it last night,
is
but I just
right
went through it,
here. Okay? So what is going on, or actually I'd like to use the example that's right up here. Same idea. So let's write this out.
I think it's adding phosphate.
It's already gotten before.
We have a molecule here called diphosphoglyceric acid. And it's a substrate because it's basically going to be converted into a product. So those are pretty generic terms, substrate, product. So here's our substrate. And it's going to be converted into a product, which is called 3-phosphoglyceric acid. Doesn't really matter, but you can use the names to give you an idea of what's going on. And you'll have this in front of you if you do the extra credit. So we have a diphosphoglyceric acid, and then the di disappears, and now we just have 3-phosphoglyceric acid. So what's happening here?
Adding phosphate.
We're losing a phosphate from our substrate because here we have a diphosphate, and now it's just telling us 3. What's that 3 mean again? It's the position of where the phosphate is located. So here it's not telling us, that's just how naming goes. It never is consistent, unfortunately. But it's telling us we have 2 phosphates by saying diphospho. Now it's telling us we have a phospho group on the 3rd carbon, which means we only have 1. So we're losing a phosphate. That phosphate, where's it going?
Getting
To
added.
ATP. It's getting added to ATP. So at the same time, conveniently, we have this adenosine diphosphate over here. And so the phosphate's going to get added to that. And that is going to now result in the formation of an ATP. So we have substrate level phosphorylation because the phosphate group is coming from our substrate and it's phosphorylating our ADP. So this is an example of it happening in glycolysis. It also is happening in the TCA cycle.
Which is also the Krebs cycle.
Also the Krebs cycle. Yep. Krebs, TCA, citric acid, whatever you like. Any questions about that? So that's substrate level. It makes a whopping 1 ATP. And then it happens again down below, which makes another ATP. So awesome, we get a total of 2 ATPs that are made, okay? Now, oxidative phosphorylation is only happening in one spot. Right here. Whoa. There's our ATP synthase. Okay, so oxidative phosphorylation is happening right, come back, right here. Same kind of reaction, it's a phosphorylation. ADP is getting a phosphate group added to it, but it's not being donated from the substrate. This machine is doing it. And coupled to the reaction of the ATP synthesis is also oxygen accepting electrons, resulting in a water. So that's how I like to remember it. Oxygen is receiving the electron, so it's oxidative phosphorylation. But really the reason that it's called that, if we zoom out, we can see why it's actually called that. There's a bunch of redox reactions happening here. So electrons are being handed off from one electron carrier to another, to another, to another. And so that means that some molecules are gaining electrons as they pick them up, and some are losing them, redox. So oxidative phosphorylation due to redox reaction. And so a question Jean had earlier was, well, aren't redox reactions happening in glycolysis and the TCA cycle as well? And yes, that's true. But those electrons at that point are not being coupled to ATP synthesis. They're not going to make ATP until those electrons from those reactions get delivered to here. So they're not actually going to participate in the synthesis of ATP till they get to the electron transport chain. Cool? So, back to the compare and contrast. You should be able to tell me where they happen maybe. You could tell me they happen in two different metabolic pathways. Which one makes more ATP? Oxidative. So how many ATPs does this result in per glucose molecule? Like 34-ish, 34, 30, 32-ish, 30, in the 30s. Depends on the organism. That's why we can't definitively say. But it's in the 30s. How many through glycolysis?
Like 2.
2. How many in the Krebs cycle? 2, but one at a time, right? So it's really not a profitable business. This is. Okay. Why do yeast give us the finger when we cut off their oxygen?
Because they thrive in oxygen, and so when you turn it off,
But why don't they like it?
Who's this?
they
Yeah.
can't react anymore.
Yeah, so we cut off oxygen. This step is also cut off. No more electron transport chain for the yeast. So instead of being able to make ATP in the 30s, they can make the ATP that they get to make in glycolysis, and they travel from there to the fermentation pathway. So really all that they can participate in for ATP synthesis is glycolysis, which gives them a whopping 2 ATPs per glucose molecule. If they're only allowed to make 2 ATPs, that's going to significantly slow down the amount of energy that those guys have. And so from there on out, they're not going to be able to reproduce properly. They can't carry out normal functions because they're on low energy. If I starved you guys, you'd be pissed, right? Same idea. You would be tired. You wouldn't be able to function properly. So that is why the yeast cannot. What is the goal of fermentation? Right. So the goal of fermentation, after we cut oxygen off, the yeast still have to be able to make that ATP through glycolysis. But glycolysis results in the reduction of NAD to NADH. As NAD plus acts in glycolysis, it's picking up electrons. As you can see right here. So it's picking up those electrons and becoming NADH. But now it can't go to the electron transport chain. So as soon as we use up all of our NAD pluses and turn them into NADHs, glycolysis is going to stop. We only have so many of those electron carrier molecules within our system. And so we have to regenerate that NAD plus. We have to give the NADH somewhere to drop its electrons off to. And so the fermentation pathway provides a great place for them to drop off those electrons. And it also results in products that we enjoy. Okay, what other questions? Well, if you think of anything at all, feel free to email me, and I'll be available to message you back as quickly as possible. Don't forget that your extra credit is due the same day as the exam, right? And so is your assignment, so make sure that you finish that.
Which was easier just to text it, like, hey.
I'm sorry.
Yeah, no, I agree.